Okay, so we're going on to our final couple of chapters of mechanics. And the first one we're looking at is projectiles, which is chapter 6. So you should be doing it with the PowerPoint attached on Show My Homework. You can see I obviously tried to make my PowerPoint slightly more interesting this time, just to try and liven things up a bit as we go along. Okay, so the first thing we're going to look at is just looking at horizontal motion. So this means projecting something sideways, so it might be, throwing something out of a window, something like that, where the only motion that it is under is gravity, and the force initially, the velocity initially projected is travelling in a horizontal motion. So it's going to come down in a parabola shape. And what we can do in these particular situations is we can ignore air resistance and we can ignore any rotational movement of the particle. So when we're modelling, they're the things that we ignore. And because it's moving horizontally, there's no horizontal force or acceleration acting on it. It's only vertical acceleration due to gravity. And those facts are quite useful in terms of how you solve the problem. So in the book, I think it's a slightly bizarre way of doing it, but horizontal motion, we know that acceleration is 0, because horizontally there is no acceleration happening at all. This would massively change the shape of our projectile if this was the case. So it says you can use the formula S equals VT, which seems really strange. So you've got to think about it in 2 different ways. Either think of it in terms of V and U are interchangeable. So the initial velocity horizontally and the final velocity vertically are the same because it's a constant horizontal velocity. So whilst they use VT, most of the time in the problem, you're going to interpret it as UT. So I don't know why they haven't put S equals UT, really. You can also interpret it in terms of speed, distance and time. So we know speed is equal to distance over time. So therefore distance is speed multiplied by time. So because velocity is constant, actually we're just using distance, speed and time in sort of the old GCSE form. So that's just to explain that part. And then force due to gravity being modelled is obviously a constant, and that is the vertical motion. Obviously, when the only force being put on it is horizontal, gravity must be acting downwards and is going to cause the motion of the projectile to come down. So A is equal to G in all of these cases, and unless otherwise, G is always 9.8 metres per second, which we should already know. So I'm going to go through 3 different examples. They are all relatively straightforward. So hopefully you will be happy with the problems. On the first one, I have put the Seibert formula. I haven't on the others because they're pretty much always going to be S equals UT plus half AT squared. So example number 1. A projectile is projected horizontally at 25 metres per second from a point 78.4 metres above a horizontal surface. So just so we're clear in terms of how we'd sketch that. So we have a horizontal force, which is velocity, which is 25 metres per second. So a horizontal velocity, 25 metres per second, rather than horizontal force, sorry. And as soon as it leaves that point, it's going to start going down. Because what we have is gravity acting downwards, okay? We also know that this was 78.4 metres. So it's a really, really straightforward sketch. Find the time taken by the particle to reach the surface. So what is the time here? Now, your natural instinct might be to try and look at the motion horizontally. But we don't know the horizontal displacement. So we've got two unknowns, horizontal displacement and time. Whereas the time taken for it to vertically fall is the same as the time taken for it to horizontally fall. Okay? So time is interchangeable between the two. So I'm just going to resolve it vertically because it has got horizontal and vertical movement. I just have more information about the vertical one. Now I've put the arrow downwards because I want down to be my positive motion. Because then because it's moving downwards, gravity's moving downwards, everything is positive and it's very, very useful for me. So I know that the vertical displacement is 78.4. I know the vertical acceleration is 9.8 metres per second squared. The initial velocity vertically is 0. So initially it's not moving in any direction. There's no vertical velocity. I couldn't think of the word. No vertical velocity at all to start with. The vertical velocity changes due to gravity. Okay, so my initial velocity is 0, and t is what I'm finding out. Okay, so obviously I'm using s equals ut plus half at squared. So 78.4 is equal to 0 plus half times 9.8 times t squared. 78.4 divided by 4.9 means that t squared is equal to 16. Works out very nicely. Therefore, t is 4 seconds. So remember, time is never negative, so we don't take the negative answer as well. B. Find the horizontal distance travelled in that time. So we're trying to find the horizontal displacement. We know that t is equal to 4 seconds, so it takes 4 seconds to reach that point. We know that the initial velocity was 25, and we know that acceleration is 0. So we're still going to use s equals ut plus half at squared, but what we've got is the horizontal displacement is 25 times 4, and it's technically plus 0. So rather than trying to remember s equals ut all the time, you can just use that formula and know that because a is 0, that part will be 0. I probably won't do this for the later questions, but for now, it was just to show you that. So therefore, the horizontal displacement is 100 metres. Okay, so pretty straightforward substitutions, I think. Okay. So example number 2. I'm going to change my pen colour because I can. What am I going to use? I'll use purple. A particle is projected horizontally with a velocity of 15 metres per second. Oh, that is not a good straight line. Neither of those are a good straight line. All right, we'll deal with it. I'm not going to draw it again. So there is a horizontal projection of 15 metres per second. I know that my projectile has to fall to the floor. Find the horizontal and vertical components of the displacement of the particle from the point of projection after 3 seconds. So basically what that means is how far vertically and horizontally has it fallen in the first 3 seconds. Just need to remember, obviously I've got gravity acting down, so I'm going to resolve vertically first. So S, that's my vertical displacement. A is gravity 9.8, U is 0, and T is 3 seconds. So my vertical displacement, ut 0 plus half times 9.8 is 4.9, times by 3 squared. So my vertical displacement is 44.1 metres. I now need to resolve horizontally. That way is obviously positive because that's the way I've drawn it to be moving. So S is my horizontal displacement. There is no horizontal acceleration. My initial velocity was 15 and time is 3. So horizontal displacement is speed times by time, which is 45 metres. Perfect. Okay, B. Find the distance of the particle from the point of projection after 3 seconds. So what that means is literally where on this curve, if I was to take a direct distance, where would it be at the point 3 seconds? So I know that from this initial point, I've had a horizontal displacement and I've also had a vertical displacement. So I want to find that direct distance there. Now obviously vertical and horizontal are perpendicular, so they meet at a right angle. So I've basically just got a Pythagorean problem. So if I call this d, because we're talking about distance, then I know d squared is horizontal displacement squared plus vertical displacement squared. So d squared is 45 squared plus 44.1 squared. Obviously I'm going to do that in my calculator and square root. So it's 63.0 metres to 3 significant figures, or because we've got gravity to 2 significant figures, we can do it to 2 significant figures being 63 metres. Okay. Nice straightforward problems. Final example. I'm going to use pink. So I have my examples next to me, as I always do. It just means I don't have to worry about the numbers as I'm going along and doing this tutorial. It just makes it much easier. A particle is projected horizontally with a speed of u metres per second from a point 122.5 metres above a horizontal plane. So I can start sketching this already. So we know it's projected horizontally, but we just know that as u. So it's obviously going down like this. And I know that it's 122.5 metres above the ground. The particle hits the plane at a point which is at a horizontal distance of 90 metres away from the starting point. Find the initial speed of the particle. So I've got a lot of unknowns here. All I really know at the moment is displacement. I know that I have gravity acting downwards. Now, when I'm approaching this problem, I'm pretty much always, unless I don't know this information, going to resolve vertically first, because I know the initial velocity vertically, which is 0. So I'm going to resolve vertically. Now what I'm going to do is just think about what information that I have or need. Time is going to be the useful thing to find for when it lands on the ground, because time is consistent for both the horizontal and the vertical components. So it does make it a lot more straightforward and sensible to work that out. So I know the vertical displacement is 122.5. I know the vertical acceleration is 9.8. I know the initial velocity vertically is 0, and t is what I'm trying to find. So S equals ut plus half at squared. So 122.5 is equal to ut, so 0, plus half a, so 4.9, times by t squared. T squared is 25. They're giving us some really nice numbers. So therefore, the time taken for it to reach the ground is 5 seconds. Now I can resolve horizontally, and I've got a lot more information. I know the horizontal displacement is 90, the initial velocity is u, I know the acceleration is 0, and the time is 5. So 90 is equal to ut, so 5u, plus, or half times 0 is 0. So therefore the, oh gosh, sorry, my cat just came in and scared me because he's gone on a plastic bag and it's made a rattle. Sorry for jumping then. So u is 90 divided by 5, which is 18 metres per second. So they are fairly straightforward problems. You know, it's obviously been ignored for a while I've been filming these videos. And yeah, so that's the beginning of projectiles. So the next bit of projectiles we'll do, which we won't do in this video, is horizontal and vertical projection, so when something is projected at an angle. But for now, you can just practice exercise 6a. I've put more information on show my homework. So yeah.